recording. All right, awesome. So before we get into the Hello World traditional MNIST program for machine learning, and we'll go through the PyTorch, PyTorch and the TensorFlow version. First, I'm going to give you guys a rundown of what machine learning is and AI is. This may be review for some of you guys that are in this call right now that have already seen this presentation. So bear with me while I get through this, because this class, the beginning portion, is for these two, Blake and Garrett, that are in here in regards to one of our partner companies. So AI 101. What is AI? The definition from God, I said this wrong last time on the recording, and I'm not going to even attempt it this time. But this site defines it as the ability of a digital computer or computer-controlled robot to perform tasks commonly associated with intelligent beings. This definition is extremely broad. And so AI, when you throw around the term AI, you ideally won't get what you're looking for. When you are searching as a developer to make AI systems, that is the improper term. You don't want to use that term. If you are a company looking for AI, do not use AI in your contracts. If you're the gov, well, the gov makes up whatever words they want, and then people have to figure it out. But the gov does not use AI correctly. It's simply now more of a buzzword than anything else. Give me 1 second to close my door. So let's talk about how broad this definition is. It can be in regards to pre-programmed routes or controls for a robot or something in your computer, which is mimicking human behavior, but it's pre-programmed. It's hard-coded. So that's not real AI in the sense that you think of it now. Simple algorithms like Dijkstra and A-star for doing graph traversal is technically an AI system, but it's not AI in the sense that you think it is. Same thing with auto clickers. That's a pretty simple application to make, but it's technically AI. Anomaly detection, object detection. What type of object detection? Because there is the one that you think of now modernly, and then there's the one they made back in the 60s, 70s, which was very crude. Recommendation systems like you get on YouTube, Twitter, XYZ, those are also AI, and translation is also AI. So it's too broad. When you say that, I could be giving you something hard-coded, or I could give you something that's actually true to what term you're referring to. Now, I can't be too mad that people don't understand this, because these are the graphs that exist out there. These are things that are pulled from Wikipedia, from Medium articles, from news articles. It's extremely convoluted and confusing on what the hell is AI, what's this machine learning thing, what's this deep learning thing, why are you bringing in neural networks into this? These graphs make absolutely no sense. And they're just everywhere. So you have to know, it's funny because you literally have to know what you're doing in order to find the correct information to begin with, which is a catch-22 because you don't know what you're looking for unless you know what you're looking for. So this is what you actually want, is machine learning and deep learning, which are subsets of artificial intelligence. Artificial intelligence covers all those broad items, but machine learning is from the computer actually learning from data, and deep learning is from neural networks. Now, the data science role for developers are kind of in and out of the machine learning field depending on what exactly you're doing, because things like anomaly detection could be as simple as using Sigma 3 around your incoming data, which would be more of artificial intelligence than it would be from machine learning. So this is actually what Amazon themselves uses as a graph. I added this data science portion in just to show where the role kind of lies, but this is what Amazon uses, and it's also similar to what NVIDIA uses, which is this is what NVIDIA uses. And I'm pretty sure you don't want the AI systems made in the 50s. I'm gonna take that, you know, I'm gonna assume that because they're not as valid anymore. Machine learning didn't really come around until the 80s, with more powerful hardware coming around and realistically the big server racks. And then deep learning is just a recent breakthrough because of hardware limitations. It's funny because a lot of the deep learning methodologies and algorithms we use today were actually developed in the 50s and earlier. They were purely theoretical from little math wizards running around that were doing calculations to figure out how to do deep learning. We are just now at the point where we can actually write them up and have them run in a reasonable time on actual current systems. So machine learning is broken up into three distinct parts: unsupervised, supervised, and reinforcement learning. Unsupervised learning is basically you have data, you chuck it at it, and you say, hey, figure it out. All right? I ain't doing anything for you. All right? Figure it out yourself. And it will figure out it for you. Usually this is through clustering or dimension reduction, and these are some of the items you can get off it. We'll go into more explanation here in a second in real-world examples. There's supervised learning, where it's a lot more hands-on work prior to, but essentially instead of just chucking data to it and saying figure it out, you're chucking data that's been organized, formatted, and the answers are written in correctly, and then you give it off to it. So you're like, hey, here's a photo of a dog. All right, now learn that this is a photo of a dog. And then reinforcement learning is kind of a combo of both, where you're doing some supervised learning, but also it's doing unsupervised learning on top of that to kind of learn itself. So we'll get into these items a little more in depth. So unsupervised learning. It's kind of like a genius child because you just give it data and it gives you results immediately. So it's really nice on that front, and it helps you gain insight on your data. For example, let's say you have photos of cats and dogs and you chuck at the machine, you say figure it out. It won't figure out those are cats and dogs per se, but it will figure out that they are very similar and will group them together. Unsupervised machine learning is great for clustering of like data and doing anomaly detection, because it will figure out this data is all very similar and then this anomalous data is outside the normal bounds. Below is a picture of how data can be clustered together. Obviously, it didn't take just these words and cluster them together. There were other items tied to those words. These are just the words that are appearing on the graphic. But it will automatically figure out like these items are related to each other. This is what a lot of email filtering systems do. So when you're flagging emails as spam, XYZ, it's all unsupervised because it just looks at what's coming through using anomaly detection and tells you if it's normal or if it's anomalous in whatever verbiage it has or so forth. Now, supervised machine learning, it's kind of like a dumb child. You have this kid that doesn't know anything, and you have to constantly like show it pictures and be like, cat, this is a cat. Next picture, this is a dog. All right. Next picture, oh, this is a cat. It takes a lot longer, but it's more thorough in its capabilities. It will know for a fact and figure out what features on their face or other things it may be looking for make it defined as a cat or not as a cat. And it's used typically for classification or regression. Classification is purely tell me what the classification of this photo is, or this item, or this object. It's pretty, I don't want to say binary, it's just one result usually, like this is a car, this is a stoplight. Regression is more of prediction of time. So this can be used for predicting stock markets or how much network traffic should be coming through your network, or I don't know, anything that's over real time. Regression will help do that. Like predicting the weather would be regression because you're getting kind of like that line over time. Now, the only issue with this is it requires lots of labeled data. So every item that you feed it, you need to personally label, and that can be take up a lot of time. It's very grunt worky. So you can either do it yourself or you can offload it to third-party services like Amazon SageMaker for data labeling. And these are people that Amazon hires, and they go ahead and like label all your data for you, and you pay pennies for each like photo or video that they label. The last point I have here is it saves time for the programmer, because everything a machine learning algorithm can do, you can do it manually by programming it out, but it's going to take you a very, very long time. And this cuts down on the time because you're offloading the work to the computer. So it can help cut corners in your development. Now, this should be familiar to at least you, Blake and Garrett, that are going through college: graphs, nodes, and edges, and pretty pictures, of course. This is the basis of machine learning, and this is also the basis of stuff like Dijkstra's and so forth. Machine learning, all it is nodes and edges, and you're doing traversal across the graph. And depending on what values are on the edges or in the nodes will add up to the weight it takes to traverse that node, and it will always try to go down the path of least resistance, or maybe the path with the highest values, so with the most resistance, in order to figure out what you may be trying to identify or what it is. So this is what a neural network architecture looks like. As you can see, it's very, very similar to what I just showed you with traditional graphs and nodes, because it is graphs and nodes. The only thing is, instead of doing simple math like 0 plus 4 plus 1 to traverse, you're using other activation functions like ReLU, R-E-L-U, what is it, rectified linear unit, in order to calculate your traversals. Now, a single, two nodes with two edges connecting to some type of output node is called a perceptron. So that's the basis of all neural networks. And then from there, you can, grow it to be a bigger network. So a multi-layer perceptron is the most basic neural network type. The reoccurring neural network is a more advanced one that allows for, this is what you would use for doing graphing of data over time. And LSTM allows for you to back propagate data. So basically, instead of data just going purely forward, it can also move backwards to help modify things. Hopfield and the Boltzmann are both unsupervised machine learning algorithms. So just different ways that you can arrange things. And this is pretty simplified, but at its core, it's just nodes and edges. So you can prod these nodes in order to see what they're picking up on. So these images down here are what are generating these two images over here, and you can see that it's identifying patterns and recognizing certain key features in these images. But also, if you've partaken in drugs, which I never have, this also may feel like an acid trip or a shroom trip to you, because these machine learning items are based off of how your brain functions. So whatever your brain sees is pretty similar to what these machine learning algorithms also see. So some things that you can do on photos and videos in regards to machine learning would be classification, localization, object detection, segmentation, and the rest of these items. So here you can see a picture of classification, which is the whole entire image. Give me one overall item that's in there. So this is cat. It cannot do more than just one. There's classification and localization, so we'll tell you cat and one specific item in it. There's object detection, which will pick out all the objects inside the image and give you labels for all of those different objects. And there's instant segmentation, which is a thorough outline around each individual item that's in the scene, which getting this labeled data is a pain. There's something called super resolution, which is like enhanced in the movies, which you can see an example right here, where you can feed it blurry photos and it will give you hidden resolution inside of it. This is a predictive model, so it may fill in artificial data in between the lines that aren't actually there, so it should always be used as a grain of salt, especially if you're using it as an analyst and trying to look for hidden information. You know, maybe it gives you that the person that you can barely see in the photo, their eyes are green when you do the super resolution. Well, their eyes might not actually be greened. Maybe the machine learning model was just trained on a lot of people with green eyes, so it assumed they have green eyes. There's also these things called nerfies, which will quote unquote replace the selfie. This is made from one single image that was taken, and then the machine learning model can predict the rest of the environment to make a video. So this is just one photo that was ran through the model, and it was able to make this video from it. You can do simulation, which you've seen with deepfakes and so forth. OCR, which is character recognition, and image to text and text to image, which is pretty self-explanatory. You can have an image and just get a text response of like what's in there, and you can write up some text and get an image from it. There's NLP, which is natural language processing, which is just text only. So you can do text to speech or speech to text. You can do sentiment analysis. So whatever you just tweeted, is that positive, negative? Is it pro-US, non-pro-US? Is it terroristic in nature? Do you like guns? Do you like violence? Do you like kittens? Are you a furry? Sentiment analysis will tell you all of that based off of analyzing the text. Feature extraction is kind of what you see right here, where in your sentence it will extract key items like people that are in your sentence, locations, and organizations you're referring to. And here's another example of it down here. Topic modeling, which is unsupervised but also can be supervised, is you have 1,000 documents, you feed it to this topic modeling algorithm, and it will automatically divvy up all the documents for you and sort them by, okay, these are food recipes, these are building plans, and these are bomb construction details. Okay, maybe we should spend our time looking at the bomb construction. It's basically saves time, because instead of you going through every document one by one, you can focus on what's important. Summarization, so this is like a TLDR. You feed it a whole entire essay and you say, give me a paragraph output of what's the key points. Codex, which some of you guys might have messed with, which is also known as GitHub Copilot. Codex is made by OpenAI. GitHub Copilot basically is licensing to use Codex, but it will help you write code. Math, so it can solve math problems for you straight out of the box, some of these items. And then actual humans, OpenAI and Cohere services are pretty much real humans. You guys all heard about the Google person that quit. Honestly, pretty sure it's just a marketing scam. But OpenAI and Cohere already have services like that are available that are equally as persuasive. And that's why I classify them as humans, because it's pretty scary. With these type of systems, you can do a lot of these other items I've already put up above here automatically with this one service, because it's so intelligent and so in depth. It can do many other items that are usually one-offs. And then audio and signals. Audio files are the same as normal signals, whether it's wireless, any wireless signals, infrared, ultraviolet, whatever. They're all signal based, so any of these items can work for it. So speech to text and text to speech, super hearing, so extracting out just key things you want to hear in great detail. Noise reduction, which is used in Discord if you ever use the crisp feature. Synthesis, so you can synthesize signals from nothing. Recognition, so recognizing signals, and classification of signals. So this is a video highlighting how someone's using a mix of audio and visual recognition in order to analyze and figure out who is actually talking if it wants to play. Here we go. So when they're talking, it goes green, and when they're not, it goes red. And it can discern out of groups of people like who is actually talking or not. Additionally, this is from NVIDIA's last keynote, which was very mind-boggling. I'm going to go ahead and let it play for a second here. Let me just turn on the audio so you can hear it a little.
Welcome to GTC. We have a lot of exciting things to show you, so let's get started.
So everything in that video is 100% fake and generated with either real modeling or AI systems, including him entirely. This person is not real. They are not here. This is not a recording of him. He is digitally modeled, and the top of his torso and his face are manipulated using AI systems, and his voice is completely synthesized. That just shows you how far we have become. Everything you see is fake. Don't trust anything. Go in your bunker now and goddamn get ready for the wars. But yeah, you should know that there's a lot of stuff that's out there that is...
The Omnibus Cartel Repeal Act.
Okay, here we go. Here's also another example of synthesized voices.
The Omnibus Cartel Repeal Act, Law Number 6, will be on the bar exam.
And most people would assume that's just a recording.
The Omnibus Cartel Repeal Act, Law Number 6, will be on the bar exam.
And NVIDIA themselves have built platforms behind normal synthesis of voices for you to orchestrate the voices yourself. So basically, how the systems kind of work is you can do text-to-speech. So I write up some text, and then it gets synthesized into some type of voice I want. Let's say I'm mimicking good old Trump's voice. Now, from the voice that I synthesized from Trump, it may sound very bawdy. So NVIDIA has orchestration algorithms that are using machine learning where you can record your voice and record the emphasis and the tones that you want the Trump voice that you just artificially produced to mimic. And you can literally orchestrate voices with your voice in their inflection, which make it extremely realistic. And that's what they used in here in order to make Jensen's voice extremely realistic. So the capabilities are out there to deceive you if someone wants to, and there's definitely things that are going on to deceive you. For the love of God, when you can, use GPUs or TPUs or FPGAs. CPUs are extremely inefficient because they are not optimized for floating point calculations. GPUs, TPUs, and FPGAs are optimized for floating point calculations. Additionally, CPUs have crap for cores compared to these other items, so they can't parallelly process data in a fast way compared to these other items. So you can see here kind of graphs of how much speed compute you can get with using GPUs compared to CPUs. So 5 CPUs running against a couple GPUs, and it's not even comparable. Same thing here, you can see with the V100, which is super outdated because A100 was the next gen, and right now we're on the H100, so the speed up is incredibly faster right now. The thing is, you're going to see me referring NVIDIA a lot, because NVIDIA holds a monopoly on machine learning. AMD, what is AMD? I don't even know who they are. They don't exist. AMD is non-existent in the machine learning realm. So anything that comes out or anything that I'm showing you right now, it's not going to work on an AMD GPU at all. Now, Onyx is a library you can use that does kind of support AMD, but good luck finding tutorials on Onyx. So biases are an immense thing in machine learning, and you need to be aware of your biases because you will put them in without even realizing it. Sample bias is something that comes up a lot it's dependent usually on what country you're in. So if you're looking for photos of people, you might accidentally get too many photos of one type of race of people, or maybe just one type of specific person. Let's say they're just mostly people with brown hair and brown eyes. Well, now you take that off to Sweden, and you're going to have issues recognizing people in Sweden because they're all blonde hair and blue-eyed. Additionally, your prejudices and your measurement biases will come into play. So spend time looking up. These are just 3 biases, but spend time looking up biases. There's a whole Wikipedia article talking about like 20 different biases. Look them up, read them, and be aware of them, because you need to know of them in order to make better machine learning algorithms, because no one's going to want to buy your product if it only works on one niche of people. So this is an example of it. This looks like a photo of Obama. And when we apply super resolution on it, instead of Obama, we get Bobby Joe from next door. We don't want a picture of Bobby Joe, but this is an example of sample bias where there may have not been enough mixed colored people in the database that the machine learning algorithm used to train up to, synthesize the data properly. Additionally, you can get weird results like a 250 angry demon in the back of your closet, which is also not good. So machine learning code is a small part of the bigger structure. You will spend very little time deving on your machine learning code. You will spend most of your time collecting data and cleaning that data up, doing feature extraction, and literally everything else but actual machine learning. It is a very long, crappy process that includes a lot of grunt work and very little runtime. And it's important because when you actually run, you want to make sure you did everything correctly, because it could take days to weeks to months to run and learn off the data that you've collected. And the last thing you want is to spend a month of training to figure out that you messed up along the way and now you have to retrain. It's be very, very, very expensive. So there you can get state-of-the-art pre-trained models and data sets, so you don't even have to make them yourself from these links. For the love of God, use them. They are very good. Literally, it's just like it's just like GitHub. It's literally companies that's invested millions of dollars in these models that are giving you them for free. Why would you say no to $1 million piece of software? You're absolutely batshit crazy if you think you and your infinite wisdom is going to make some shit that's better than what they've done. It's just very extremely unlikely. Machine learning tools. These are a list of machine learning tools. If you want to do machine learning, you're going to do it in either C++ or Python. There is nothing else that you can really use for machine learning. Sure, you may be able to do inference in things like JavaScript and Java, but you're not going to be doing machine learning, real machine learning in anything else but Python and C++. Why C++ and Python? NVIDIA dominates the market. All of NVIDIA's drivers are in C++. So naturally, anything you want to do is going to be supported in C++. Python is simply a wrapper on top of C and C++, so it's very easy to port anything from C++ into Python because it's just a couple added lines of code in order for Python to utilize it. So use those libraries. There's NVIDIA Rapids, there's scikit-learn for doing unsupervised learning, there's Transformers, which has a bunch of pre-trained models that you can just continue to build off of. So you can use the $1 million models as a base and then add your data on top of it to fine-tune it. That's just fine. You can do that. Do not start from scratch though. There's PyTorch, Onyx, which is for inference, and TensorFlow. TensorFlow and PyTorch are the two biggest machine learning libraries. PyTorch is maintained by Facebook. TensorFlow is by Google. TensorFlow came out first and it took the world by storm, but PyTorch came out and said, hey, I'm going to do everything you do except way simpler and less lines of code. And everyone said, yes, please. I'm not a dude with a PhD. I don't have time to fucking learn all these goddamn specific terms that you're saying, because TensorFlow is very math heavy in its terms. So it has a huge uphill battle initially when you're trying to learn it. Not the case as much anymore. But it was the case a couple of years ago because they've embrace Keras. So as you can see, the machine learning tool landscape is pretty massive. You do not need to know all these, but it is good to take a look at this graph to know kind of what's out there. A lot of these are commercial companies and not like things you can just use out of the box. But PyTorch, TensorFlow, two things you need to know. All right, that's the end of this presentation. Time to get into some code. So I actually have a another meeting coming up in 10 minutes, so I'm going to talk about Colab a little bit before, and then we'll go on a break before we jump into this code here. So if you have a crappy laptop that can barely run Chrome, let alone machine learning stuff, use Google Colab. Google Colab is ran by Google, and it allows you to run code in the cloud using GPU and TPU architecture that they have. So if I connect this up, you'll see that I have access to resources on Google right now. You can upgrade to a pro session if you want, but let me see if, so a hardware accelerator, I can use a GPU or a TPU system. GPU is just your normal graphics card. TPU is a tensor processing unit, which is super optimized for machine learning. You can use either or. I'm going to go ahead and save that. And now I'm connecting and using a GPU. Look at that, GPU RAM. So there you go. You can get immediate access to GPU resources in order to make your stuff run faster. So use Google Colab if possible. Additionally, you're going to see this application. It's called Jupyter Lab. All of you that do not have this currently installed, you're going to want to install this. Jupyter Lab is a de facto standard for the machine learning world because it has saved states of your code. When you're running something that may take hours, you want to save that state so you can manipulate the outputs without having to rerun the hour-long piece of code again. You'll see more in depth on how this is important and extremely valuable, but in order to run this, I'm going to go ahead and close this. You just do pip install. Let me zoom in a little bit on this. Come on, zoom in. Why won't you zoom in? Why are you doing this to me? All right, well, it's pip install Jupyter Lab. So I already have it installed. I'll go ahead and drop that in the chat here. So that way you guys can install it. After you install that, to get it up and running, you run the command Jupyter Tac Lab. And that will get a Jupyter Lab instance running for you. And it will default, the directories that are available on the side will default to wherever you ran that command. So go ahead and from there navigate to wherever you need to. And you are going to not be using .py files. You're going to be using .ipynbxglykabc files. These files are specifically for notebooks, and they allow you to, let me go and open a new one. They allow you to make these little segments, which you can create multiple of, and these will have saved code states. So I can do like x equals 5 or 6 in here, and I can run that, and this now ran and its save state is here. So if I go down here and press X, it will see output of 6 was right here. If I move this down to here and change this to 5 and press play, the value is 5, even though there's code right here, because I didn't run this code yet, and this was ran on step 3. So if I run this, now this is on step 5. Step 5 is further than 3, so this has been overwritten. So if I click play again, the save state is now 6. And if I click this top one again, it will replace it to now 5. So if you do some type of machine learning thing that takes an hour, it will save the state, and you can manipulate its items later down the line without having to rerun all of your code again. All right. So let's go ahead and take like I'm going to guess it's going to be potentially like 30 minutes. Are there any I got 5 minutes left before we got to take this break, and then we'll continue on with the code here to do the Hello World machine learning stuff. Are there any questions right now before we jump on the break? Anyone else? Yeah, sorry again, just unexpected meeting this morning, and this meeting was planned, but I forgot about it. But it shouldn't take too long. All right. Well, I'll have Discord open and the chat open, so just ping me if you have any questions. We are going to continue hopefully in like 30 minutes. So go ahead and get some food, whatever else you want to do, and we'll be back.